In the final years of the Second World War, Germany's obsession with superweapons reached its most extreme form. By 1944, as Allied armies closed in from both east and west, the Nazi leadership had lost faith in conventional solutions. Instead, they turned toward projects of unprecedented scale. Machines so large, so advanced, and so impractical that they could exist only as symbols of a collapsing regime. Among them was the heaviest tank ever built, the Panzerkampfwagen 8 Maus. The Maus was a creation of excess. It was not designed to win a specific battle or to fit any real tactical doctrine. It was born from an idea that invincibility could be engineered through sheer size and armor. The result was a machine weighing nearly 200 tons, larger than a small house, and slower than a marching soldier. It was a tank conceived without regard for logistics, fuel, or mobility. It was the physical manifestation of a fantasy, that technological might alone could reverse Germany's defeat. The story of the Maus began in 1942, when the German Army's High Command issued a request for a new super-heavy breakthrough tank. The project was initially proposed under the code name Mammoth, and later renamed Maus, or Mouse, in a touch of ironic understatement. The primary figure behind its development was Ferdinand Porsche, one of Hitler's favorite engineers. Porsche had already designed the failed Tiger P tank and had a reputation for ambitious, over-engineered designs. For the Maus, he would be given nearly free rein. Hitler personally supported the idea. Obsessed with gigantic machines, he saw the Maus as the ultimate expression of German superiority. He imagined a tank impervious to all enemy fire, capable of crushing any fortification or vehicle in its path. According to his vision, a small number of these supertanks could dominate entire battlefields through fear and destruction alone. In practice, however, the idea was detached from military reality. The Maus was to weigh 188 metric tons in its final design, nearly 3 times heavier than the Tiger II. Its frontal armor was to be 240 millimeters thick, and the turret armor up to 220 millimeters. No existing Allied gun could have penetrated it frontally. Its armament was equally ambitious. A 128 mm K-44 L-55 gun paired with a coaxial 75 mm K-44 L-36.5 secondary cannon. The combination would allow it to destroy any known tank from extreme range. But the sheer size of these weapons created immediate problems. The enormous turret had to be cast as a single piece of armor weighing over 50 tons, and rotating it required an electric motor powerful enough to drive a small vehicle on its own. Porsche's engineers faced impossible challenges from the beginning. The tank's weight was so immense that no existing bridge could support it. To cross rivers, the Maus would have to ford them underwater, using a snorkel to breathe through the surface. Its 1,200 horsepower Daimler-Benz engine, adapted from naval applications, could barely move the machine at 10 kilometers per hour. Even at that speed, it consumed fuel at an alarming rate, limiting its range to less than 200 kilometers under ideal conditions. Power transmission became another nightmare. Porsche had long championed hybrid electric drive systems, using gasoline engines to power generators that drove electric motors in the tracks. In theory, this would provide smooth acceleration and torque control. In practice, the system overheated constantly, suffered from reliability issues, and required rare materials like copper that were already scarce. Nevertheless, the prototype went ahead. By mid-1943, as the Battle of Kursk unfolded, Germany was already losing the strategic initiative on the Eastern Front. Yet resources were still diverted to the Maus. Hitler ordered that production begin even before testing was complete. The first prototype hull was completed at the Alket factory in Berlin in December 1943, followed by a turretless version for trials. The full prototype, known as V1, rolled out in early 1944. A second hull, V2, was under construction at the Krupp plant in Essen. When the mouse prototypes were tested at Kummersdorf and Böblingen, the results were both impressive and absurd. Its armor was indeed impenetrable to all known weapons. Its firepower was devastating, and its precision was remarkable for such a massive gun platform. But the tank could barely move without breaking roads and bridges beneath its weight. It destroyed its own transport routes, leaving deep ruts in asphalt and tearing up rail lines. Maneuvering it required carefully prepared terrain and constant mechanical attention. Transporting it to a battlefield was almost impossible. In battlefield conditions, the mouse would have been a liability. Its enormous size made it an easy target for aircraft and artillery. Its limited mobility meant that it could not retreat or reposition once engaged. Its engine was so loud that it could be heard from kilometers away. And its fuel requirements were catastrophic at a time when Germany was already suffering severe shortages. Even if deployed, it would have required an entire logistical operation just to keep it running for a single day of combat. Despite these issues, Hitler continued to push for production. He envisioned entire battalions of super-heavy tanks leading assaults, breaking through enemy lines where smaller tanks failed. By 1944, he demanded that Porsche and Krupp find ways to mass-produce the mouse at the rate of 10 per month. Engineers knew this was impossible. The steel alone for one tank required as much material as 5 Panthers. The factories were already under Allied bombing, and Germany's industrial base was collapsing. Still, the Führer's orders could not be ignored. In secret meetings, German generals expressed frustration. They saw the mouse as a waste of precious resources that could have been spent on practical designs like the Panther or the Jagdpanther. Albert Speer, the Minister of Armaments, tried to slow the project, arguing that it was pure madness. But even Speer could not fully cancel it until Hitler's attention shifted to even larger projects, such as the Rata, a proposed 1,000-ton land cruiser that would never leave the drawing board. The first mouse prototype conducted limited tests in early 1944. Engineers examined how it handled rough terrain, water obstacles, and firing sequences. It performed well in controlled conditions, but broke down repeatedly. The second hull, V2, was eventually fitted with a complete turret and tested in late 1944. But by then, the war was effectively lost. Allied forces were bombing German cities, and Soviet armies were pushing deep into Poland. The idea of fielding the mouse had become irrelevant. It was a tank for a war that no longer existed. As the Red Army advanced into Germany in early 1945, engineers at the Kummersdorf Proving Ground received orders to destroy both prototypes to prevent their capture. The first hull, V1, was partially destroyed, and the second, V2, was damaged but left intact enough to be captured by Soviet troops in April 1945. The Soviets combined the intact hull of one with the turret of the other and transported the assembled mouse to their proving grounds for evaluation. There, they discovered the extent of its impracticality, an engineering marvel that was militarily useless. In the aftermath of the war, the mouse became a symbol of Nazi overengineering, a project that embodied the delusions of power that had driven the Third Reich. It had consumed enormous resources, diverted skilled labor, and achieved nothing on the battlefield. For historians, it represented the logical extreme of a philosophy that valued spectacle over strategy. After the war ended, the captured mouse was transported to the Soviet Union. The Red Army's engineers were eager to study it, not because they planned to build anything similar, but to understand how far Germany's technology had gone in its final days. The reconstructed mouse, assembled from the V1 hull and V2 turret, was tested at the Kubinka Proving Grounds near Moscow in 1946. There, Soviet specialists dismantled and examined every component, from its massive suspension system to its complex electric transmission. The results confirmed what the Germans themselves had already realized. The mouse was not a practical combat vehicle. Its armor and weapons were impressive, but its mobility was non-existent. The hybrid drive system was fragile and difficult to maintain. The tank's weight made it almost immovable outside of prepared terrain. Even the Soviets, who were fascinated by heavy tanks and would later produce designs like the IS-7, found the Maus absurdly overbuilt. After the testing program, the tank was abandoned. Today, the only surviving Maus, the one assembled from the captured prototypes, remains at the Kubinka Tank Museum, a silent monument to the excesses of wartime engineering. In the years following 1945, the Maus became a subject of fascination and disbelief among military historians. It represented the peak of a broader trend within the German war machine, the pursuit of so-called Wunderwaffe, or wonder weapons. These were technological marvels that promised to change the course of the war through sheer innovation: the V-2 rocket, the Me-262 jet fighter, and the Type 21 submarine. Each was an extraordinary technical achievement, but each arrived too late and too few in number to make any real difference. The Maus was perhaps the purest expression of that phenomenon, an invulnerable tank that never fought, a machine that existed only to prove that Germany could still dream of victory, even as it collapsed. The concept of the super-heavy tank did not begin or end with the Maus. Before the war, several nations had experimented with large armored vehicles. The French had developed the Char 2C in the 1920s, a 70-ton behemoth that served more as propaganda than as a combat unit. The Soviets built multi-turreted monsters like the T-35, which were powerful on paper but mechanically unreliable. Even Britain had designed massive land ships during World War I. But by the 1940s, tank design philosophy had shifted toward balance, combining mobility, firepower, and armor in equal measure. The Maus ignored that evolution entirely. It represented a regression to the idea that bigger is better, an idea rendered obsolete by advances in anti-tank weapons and air power. By 1944, the battlefield had changed beyond recognition. Air superiority ruled the skies. Artillery and aircraft could destroy heavy armor long before it reached the front. Even the Tiger II, far lighter than the Maus, suffered catastrophic losses due to breakdowns and fuel shortages rather than enemy fire. The Maus, had it been deployed, would have faced a similar fate. Allied bombers could have targeted it easily. It would have been too slow to evade, too heavy to hide, and too important not to attract every enemy gun within range. Its sheer size was not a shield, it was a beacon. The Maus project also illustrates the disconnect between Germany's engineers and its strategic reality. While Allied industries focused on mass production and reliability, Germany pursued perfection through complexity. Tanks like the Panther were technologically advanced but difficult to manufacture. Each required thousands of man-hours, precision machining, and rare materials. The Maus took this to an extreme. Building one consumed resources equivalent to dozens of standard tanks. The same amount of steel, fuel, and labor could have equipped an entire armored battalion. For a nation already struggling to supply its front lines, the Maus was a black hole of effort. There were also deep logistical contradictions. A single Maus required a custom rail car for transport, and even then it could only travel on specially reinforced tracks. Its engine consumed nearly 4 liters of fuel per kilometer. Its tracks were so wide that they destroyed roads, and its bridge crossing capability was effectively zero. To operate one in combat, engineers had to prepare the terrain in advance, laying down wooden supports and steel mats. The idea of rapid maneuvers, the very foundation of German blitzkrieg doctrine, was incompatible with such a vehicle. It was a machine that could neither blitz nor retreat. In hindsight, the Maus was less a weapon and more a psychological artifact. It reflected a regime trapped between technological ambition and political delusion. By 1943, when Porsche's design took shape, Germany's defeat was already a matter of time. Yet the leadership continued to demand superweapons, as if sheer engineering could reverse the strategic tide. In that sense, the Maus was not designed for war, but for morale. It was a promise to the German people that victory was still possible, that the Reich could still build something no one else could. In reality, it was a promise built on steel and denial. Some historians have described the Maus as a tank of despair. It represented not confidence but desperation, an attempt to regain lost prestige through spectacle. The same mindset led to the development of the Ratte, a proposed 1,000-ton land cruiser armed with naval guns. That project never advanced beyond sketches, but it reveals how detached the Nazi leadership had become from reality. Instead of building practical weapons, they dreamed of giants that could never move. From an engineering standpoint, the Maus remains a fascinating achievement. Its armor was the thickest ever applied to a tank. Its gun, the 128mm KK-44, became the basis for later anti-tank and tank destroyer weapons. Its suspension system, though overcomplicated, was exceptionally smooth. The electric drive, while unreliable, was decades ahead of its time in concept. In theory, it anticipated hybrid propulsion systems now found in modern heavy machinery. But in 1944, such innovation was useless without the means to sustain it. The German industrial system, already overextended, could not produce the precision components or electrical materials in sufficient quantity. The Maus was thus a technical marvel without an ecosystem. In the immediate post-war years, Allied engineers also examined the idea of super-heavy tanks. The United States developed the T-28, a 95-ton assault gun intended to breach fortifications. The British experimented with the Tortoise heavy assault tank. The Soviets considered the IS-7, weighing around 68 tons. Yet each of these programs was short-lived. By the early 1950s, the era of super-heavy armor was over. The advent of shaped-charge warheads and portable anti-tank missiles made extreme armor thickness obsolete. Mobility, firepower, and adaptability became the defining principles of modern tank design. Today, the Maus stands as a cautionary tale. It demonstrates the limits of engineering when divorced from strategy. A weapon can be perfect on paper, yet useless in reality. The Maus could have dominated any one-on-one tank duel. But wars are not decided by duels. They are decided by logistics, production, and adaptability. In those fields, Germany had already lost long before the Maus was built. The tank story also raises broader questions about the relationship between innovation and desperation. In times of crisis, nations often turn to technology as a savior. The Third Reich's late war projects mirrored this pattern, investing hope in machines rather than men, in prototypes rather than armies. The Maus, like the V-2 rocket, symbolized that misplaced faith. It was the ultimate example of how technological brilliance can coexist with strategic blindness. The Maus never fired a shot in anger. It never rolled into battle, never faced an enemy, and never fulfilled the purpose for which it was designed. Yet its legacy endures. For military historians, it represents both the height and the folly of wartime engineering. For engineers, it remains a study in extremes, a machine built at the edge of possibility. For visitors to Kubinka, it is a relic of a time when humanity's imagination outpaced its reason. The lessons of the Maus continue to resonate. In the decades since World War II, militaries have repeatedly faced the temptation to chase superweapons, machines so advanced that they promise to render all others obsolete. Yet history shows that the same principles apply. No amount of armor can protect a flawed idea. The Maus reminds us that technology alone does not win wars. Understanding its purpose does. In the end, the Maus was not a monster that fought, but a monster that revealed the truth. It showed how far a nation could go to deny its own defeat. It demonstrated that brilliance, when guided by delusion, leads only to ruin. And it proved that the greatest weight a tank can carry is not its armor, but the burden of the dreams that built it.